Today, we're going to handle some sort of logic puzzles dealing with all we know about sine, cosine, and tangent. So, to start off our notes, I want to kind of think back to our unit circle, our definitions of sine, cosine, and tangent, and just cover some things. So, got this image over here, just kind of reminding us what's happening with this unit circle. As we rotate our radius around the unit circle, we can always create a triangle. The height of that triangle is going to be y, our y coordinate, and that's going to be what sine is equal to. That co-height, or the side-to-side distance, is going to be x, and that's what our cosine is equal to. Then, as we discovered a couple days ago, tangent is simply going to be sine divided by cosine. So start by jotting down these notes into our page here. Then, if you move to the right, we have a kind of blank unit circle with our different quadrants listed 1, 2, 3, and 4. And we just want to reiterate what those behaviors are of sine, cosine, and tangent as we move around the unit circle. So in our first quadrant here, if we had a rotation that landed here, all three functions, sine, cosine, and tangent, are going to be positive. Sine because it's above our y-axis, cosine because it's to the right of our y-axis, and tangent because we have a positive divided by a positive, which leaves us with a positive. So if we move over to quadrant 2, in this case, sine would still be positive, but our cosine is negative now because we flipped to the left side of our y-axis. And that means if we take sine divided by cosine, we'd have a positive divided by a negative, which would give us a negative. So as we move around the circle to the third quadrant, now sine and cosine both become negative, tangent would become positive. And the fourth quadrant, sine is negative, cosine is positive, and that means that tangent would become negative. So I've also included on your note sheet just a reminder of some of our trigonometry formulas. Here's our SOHCAHTOA, so how we calculate sine, cosine, and tangent from our different side lengths, and how we can calculate the Pythagorean theorem here, a squared plus b squared equals c squared. And I can see right now I've made a mistake on our note sheets. This tangent here should be opposite over adjacent. So if you see this, cross out hypotenuse for me, and let's write in adjacent as our lower fraction there. So we're going to go through two examples, kind of tying everything in together, our unit circle knowledge, our triangle knowledge. So first things first, if we're given cosine of theta equals negative 8 over 17, we're going to want to choose all the possible values of tangent from the given values below. So we're going to kind of have to logic our way through and say, okay, which one of these are possible here? So let's start with what we know about cosine. If I have a negative cosine here, so if we have this negative cosine here, then we know that we are going to be in quadrant 2 or 3. And let's look back at our unit circle, right? If we scroll back to this slide, we can see that my cosine is negative in quadrant 2. It's also negative in quadrant 3. So that's one thing we know. We also know that my cosine is equal to the adjacent side divided by the hypotenuse. And in this case, that means that our adjacent side is equal to 8. And my hypotenuse is equal to 17. So finally, something we know is that our tangent, we know that that is going to have to be our opposite over our adjacent. So we don't know what our opposite is yet. So opposite equals question mark. However, we do know that our adjacent equals 8. So that means the bottom of our fraction is going to have to be equal to 8. We can cross off both of these values right now if we wanted to. We also know that because we're in quadrants 2 or 3 here, that our tangent can be positive or negative. So tan is positive or negative here. So in this case, we can probably rightly assume that, hey, it's got to be 15 over 8 has to be our answer, right? And we can verify that in a second, but I'm going to say that, yeah, tangent can be positive 15 over 8, or it could be negative 15 over 8. And here's how we can verify that 15, just in case we needed to do a check. If we sketched a little triangle here, little right triangle, we started labeling our sides, and let's throw our theta down here. We know that our adjacent side is 8, our hypotenuse is 17, and our missing side is opposite. We don't know what that is. Let's call that A for now. We can set up a Pythagorean theorem. We can go a squared plus 8 squared equals 17 squared. And as we work that through using our Pythagorean theorem, we'd find out that A is equal to 15. So in this case, those purple steps we didn't have to do. We were able to kind of reason through our answers without doing that. But it was kind of a nice to do. So there's one more kind of logic puzzle we're going to go through together before I let you work in your groups to fill the backside of the sheet. And this one says, all right, if sine is greater than 0 and cosine is negative 15 over 7, then we want to find tangent. So same as before, let's kind of take a look at our unit circle. Sine is greater than 0. So that means sine is going to be positive. So that's got to either happen in quadrant 2 or quadrant 1. So let's go back here. Let's kind of jot that down. We know if sine is greater than 0, we're going to be in 1 or 2. We also know that if cosine is negative, that we are going to be in 2 or 3. So in this case, since we have to be in 1 or 2 for the sine requirement, or 2 or 3 for the cosine requirement, we are going to have to be in quadrant 2. So we know we're in quadrant 2, which means that our tangent function, if we jump back, our tangent function is going to be negative. So tangent is going to be less than 0 or negative. Then we want to figure out the actual numbers that are going to be used in tan. So let's draw a kind of sketch of what we know right now. Let's make a little triangle to help us out. We have this triangle. Let's put a right triangle sign there. Let's put a theta there. And we know from cosine here, cosine of 15 over 17, that my adjacent side has to be 15. My hypotenuse has to be 17. And we don't know what that last side is. So we can start doing our Pythagorean theorem if we want. I'll do those steps in pink here. C is 17. I'm going to put B as 15. And we're going to solve for A. So in this case, we have A squared plus 15 squared equals 17 squared. So I'm really sorry. I got distracted by another teacher that just walked into the room. So I will kind of restart where I think I left off. Forgive me if I'm duplicating the work. So we are going to kind of sketch a triangle to help us visualize what we know about this cosine right now. And if we write a triangle here, okay, our cosine is 15 over 17. So we know that the adjacent side needs to be 15. My hypotenuse needs to be 17. And we can start doing the Pythagorean theorem to solve for that missing side. We have c equals 17. In this case, we have b equals 15, and we're going to solve for a, which is also our opposite side here. So if we do that, we get a squared plus 15 squared equals 17 squared. That'll bring us a squared plus 225 equals 289. We can subtract 225 from both sides and leave us with a squared equals 64, which then means that a is equal to the square root of 64, which is equal to 8. And again, that is our opposite side. So we know that tangent is negative. We know that opposite equals 8, and we know that the adjacent side equals 15. So in that case, our tangent is going to be equal to negative 8 over 15.